Hey everyone. Thank you very much for coming to my talk. Really appreciate it. My name's Phil. I'm an Android developer at Shopify based in Toronto. And I'm here today to talk about the Kotlin Serialization library. So there's only 20 minutes and there's sort of a lot of examples to squeeze in, so I might be going through it pretty quick, but we're basically going to talk about what it is, what the library is, go through some examples, make you aware of any issues that you might run into should you want to use it, and hopefully at the end we'll be able to answer those two questions right there. That's sort of the goal of the talk. So the first question probably is, what is Kotlin serialization or Kotlin X serialization? I'm going to be using the two terms sort of interchangeably. Basically, it's a data serialization library that's been developed by JetBrains, who we all know. And it consists of two things. It consists of a compiler plugin, which is used to generate serialization code for the classes that you want to serialize, and a runtime library which uses that generated code in order to actually serialize the objects. At the moment, it supports a few formats. We're going to focus on JSON for this talk, but if you're interested in some of the other formats, there's lots of examples on the the project repo on GitHub. And oh, sorry, hang on just a second. I lost focus. There we go. And it's an experimental API, so it is sort of under heavy development, and so there's no guarantee of API compatibility between versions. So just something to be aware of. Okay, so how does it work? It's actually pretty simple. Basically, any class that you want to serialize, you just mark with the serializable annotation. And what that does is it tells the compiler plugin to generate serialization code for that specific class. And if you're not happy with the generated serialization code, then you can use custom serializers to define your own serialization behavior. Okay, so sounds great. So how do we set it up? Again, pretty simple. First, we just need to add a dependency to the plugin in our projects build.gradle file. And then in the module that we're going to be using it in, we just have to add a dependency to that plugin and then add a dependency for the runtime library. So pretty simple. And when we actually want to start using it, sort of the two pieces of the library we need to interact with are, first is a JSON configuration. We need to create one of those. And we use that to create a JSON instance. So the JSON instance is what we will be using to actually interact with the library and do the serialization. And the configuration sort of has the information that the library needs in order to properly do the serialization. You can create your own configuration, but there are a couple sort of standard ones that come out of the box. The one that's recommended is JSON configuration.default. However, it is subject to change from version to version. There is another one which is JSON configuration stable, which is it is guaranteed to stay the same from now until version 1.0. At the moment, the stable and the default implementations are actually the same, so it doesn't really matter what you use, but that's not guaranteed to stay the same. And just to sort of give you an idea of what's in the JSON configuration, this is what the class looks like. So it's essentially just a series of properties that you set when you create the class, and it sort of defines the output and of the behavior of the library. And the nice thing about this is that it's actually a data class, and so that if there's a situation where you want to keep an existing configuration and just change one or two parameters, you can do that quite easily just by copying the implementation and changing the parameters that you're interested in. Okay, so I've been talking for a couple of minutes about setup, and I can see it in all your faces. You are super excited to start serializing some objects, so I'm not going to make you wait any longer. So let's get started here. So I like baseball, so I made a class that just represents a baseball player. And it's pretty simple. It's got some primitive fields in it. It's got a first name, a last name, and just a number that they'd wear on the uniform. So if we wanted to go ahead and actually serialize this, as I mentioned, the first thing we do is just mark that with serializable. And then when we actually want to go and serialize it, we call a method down here on the JSON object, which I mentioned a few slides earlier. And we call a method called stringify, and that basically just takes the object and converts it into a JSON string representation. The method takes two parameters. One is a serializer, and that's the code that is generated by the compiler plugin, so that knows how to serialize those values into JSON. And as you see, it's actually the serializer is generated on the object's companion, so you can actually reference it in a sort of a static context like that. And then we just pass in the instance of the player that we want to serialize. And when we're all done, it just, no surprise, it just converts it into a JSON string. And we can get excited. So that case was sort of pretty easy, and it's basically just taking one field and converting it to or each field converting it to JSON. But in a lot of cases, we might say want to customize the field name, such as use snake case for the field. So in that case, we can just use the serial name annotation and just toss that on there. And then when we call the exact same code to serialize it, it now just gives it with the fields as we expected. So I mean, that's pretty standard with other serialization libraries. And so in the situation where we want to parse it back from the string to the actual class implementation, we do a similar sort of thing. We once again interact with that JSON object, but we call a parse method. And in the parse method, again, we give it the same serializer, and then we give it the JSON string of the class that we're trying to, or of the class we want to create. And then, no surprises, it just creates the JSON or the class instance for us. So that's great for just sort of a single class, but being Android devs, we quite often have to deal with lists of objects. So what if we have a list of players? Well, it turns out on the serializer that's generated, there's a few convenience properties that you can use in order to serialize collections. So in this case, we basically use the exact same code, but at the bottom you notice that we're actually calling a list property on the serializer. And so what that does is it knows how to serialize lists of that specific object. And so now when we do it, no surprises, it just serializes the list of objects for us. There's a couple of other of these properties. There's ones for map and set, I believe. So you won't have to do any extra code to serialize a collection of objects, which is cool. So moving along, what if we have a property that we sort of optionally want to include in serialization? So here I've taken the class that we've created and I've just added a nickname field. And it's an optional and it may or may not be present. And if we serialize it with the standard method we've been using up until now, you'll notice that for this player in particular, there is no nickname, but it still is encoded as null. But what if we don't want to include it in their serialization if it doesn't have a value? So because that value has a default value, if in our JSON configuration we can actually set one of the properties, the encode default value to false. And so in this case, if the property has a value that's equal to its default value, it will not be included in the serialization. So now when we do it, it's missing. So this is sort of the way you can make properties optional if that's what you're looking for. So a couple other sort of handy tools to be aware of. Based on that last example, you might be thinking, well, okay, but what if I have encodes defaults to false, but I have a property that I always want to include, even if it is its default value? Well, in that case, you just use the required annotation, and if it has a default value, it will always just be included. And conversely, if you have something that you never want to include, then you use the transient annotation. Pro tip, make sure you use the correct transient. There is a Kotlin X serialization transient, which is the one you want, and there's a Kotlin JVM, which is what you don't want. And don't be like me and sit there for 10 minutes trying to figure out why it's not working. Just make sure you use the right annotation. So far we've just sort of been just a basic class of primitives, but what if we sort of have nested classes? So in this case, I've created a team class that basically just has a city, the name of the team, and then a list of players that play on there. And in this case, to serialize this, we give it the serializer for the team class, and that spits out exactly what we're expecting. Nothing too fancy here, and because the team class is serializable, the player is serializable, they all know how it works together, so it gets serialized no problem. But what if we have a case where we have generics? So in this case, the compiler plugin doesn't know what it's trying to serialize, and so it doesn't know how to generate the code for it. So in this case, I've just sort of created a basic sort of message class that just takes a data payload of type T. And in this instance, we'll have a message that just takes a player object, which we've been working with for the last few minutes. And when we actually want to serialize that, what we want to do here is you'll notice that we pass in the message serializer, because that's the class that we're trying to serialize. But you'll notice that serializer actually takes an argument now. And so when you're serializing generics, you have to actually pass in a serializer for each generic type that the sort of parent class has. So it basically just delegates responsibility for serializing to the class that knows how to serialize it. So in this case, we just pass in a player serializer to our message serializer, and there we go, and everything's good. All right, so with continuing on with our examples, let's add some statistics for our player. So we've sort of set up our statistics. It's a sealed class that has two sort of implementations for hitting statistics and pitching statistics. Not really important what's in there. They're all just basic primitives. So, but the important thing here to sort of look at is that we have two distinct implementations of a base statistics class, and we're trying to serialize this statistics class. So, like, how are we going to do this? Like, well. Turns out it's pretty easy, and all we have to do is toss on a polymorphic annotation to the base class for statistics. And we then, when we're setting up our JSON instance, we pass in an additional parameter where we pass in what's called a serializers module, which is basically just a map of class to serializer. So you're basically saying, okay, when I have pitching, I'm going to use this serializer. When I have hitting, I'm going to use that serializer. And we give that to the JSON when we create the instance. And then now when we actually go to serialize it, it works out just fine, and using the exact same code we had before. So yeah, it's pretty handy to be able to do that, and that's sort of inherent support of the polymorphism and sealed classes. Okay, so let's now add a position for our player. So what position does this player play? And that's just defined as an enum, and it basically just has one entry for each position. And each position has an integer ID that we can reference and by if we want. And so when we go to serialize this using our sort of standard method, works great. And you notice that the enum is basically just translated directly into the property. But what if we don't want that? What if we actually want to serialize the ID instead of the name? So this is where custom serializers come into play. So we can actually define what we want to do with the serialization. So in order to implement a custom serializer, you implement a K-serializer interface, which comes with the library. And, oh boy, what happened? There we go. Sorry, I missed a slide. So really, there's sort of two methods that you want to be aware of. One is the serialize method, and in here is where you're actually handling the serialization. So you're saying, okay, we've got our position class, and we're just going to encode the integer value instead of the name, and then. Sorry, I got some extra slides in there. And then in the deserialize method, then we're decoding that serialized integer and creating an actual object from it. So here we're actually defining what we want to do. So now we can go back to our class definition for position, and you'll notice up at the top we're marking it as serializable, and we're actually specifying which serializer we want to use for this class. And we're using the position serializer, which we just created. And now when we do the serializer, it comes up with the ID instead of the value. So exactly what we were looking for. Okay, so now let's add some more properties. Let's add a handedness property. So this is basically if the player uses a left-handed, right-handed stance, or both to bat or throw. And we've implemented this as a sealed class with 3 objects representing the 3 cases. And when we now go to serialize this, we actually run into a bit of a problem. And you'll notice in the bats and throws in the serialization, they're actually just empty. And this is because the Kotlin Serialization library, as of now, doesn't know how to serialize objects, which is kind of a pain. So we're like, okay, so how do we fix this? Well, we just create a custom serializer. So in this case, we can basically say, okay, for each value of handedness, we're going to encode it into a string. And then when we're coming back, we're going to do the opposite, go from a string into the object. We once again mark that class as serializable with that specific serializer. And then now when we do it, we get the output that we're expecting. We're getting a string value of left or right. So this is, I mean, you can handle it, but it's just really annoying to have to write a serializer for every object that you have, especially if you have a lot of objects in your app. But this is an issue that the library maintainers are aware of, and object serialization is scheduled to be included in the 1.0 release, but it's just not available now. So it's just something you sort of have to be aware of. Okay, so what if we have a situation where we're trying to serialize a class that we don't own? So in this case, we've just added a birth date for the player, and we're going to use the date class. And so in this case, we don't have control over the date class, so we can't go and put a serializable annotation on it. So in this case, we just sort of write a custom serializer, which we've been doing in the past couple of slides. And in the class itself, above the property, we can actually specify that this is serializable with this specific serializer. And now when we go to serialize it, we get the birth date that we're expecting in the format that we're expecting. So it's kind of nice so that you can, the way that you use the library is tagging these classes with serializable, but it's still flexible to be used with classes that you can't actually do that. So pretty handy. Okay, so being a room full of Android developers, we're probably all wondering also this question. And the answer is yes, because obviously Jake Wharton has written a converter factory for Retrofit to use the JSON or to use the Kotlin serialization. So to test this, or so to use this, it's basically you just include that in your project as always. And when you are creating your Retrofit instance, you just use the library actually creates an extension property on the JSON object, so you can use it as a converter factory for Retrofit. And so to test this out, I use the My JSON server service, which basically lets you host sort of fake JSON data on a public GitHub repository and then retrieve it through a REST endpoint. And so I tossed some data up there, and I created a Retrofit service just to get a list of players. And to test it out, I just wrote a basic test where I had a list of players in a list of classes, of class instances, and I go and get the data from Retrofit. The two should be equal, and we just test if they are, and it was. So good stuff. So we've been seeing a lot of cases on how you sort of do certain things, but there's definitely some things you need to be aware of that when sort of using the library. First off, you got to be aware of property visibility. In your constructors, you can't have parameters in any class you want to serialize. You have to have properties, so vals or vars. And as well, in a class property, you can't serialize any computed properties. So the property specifically has to have a backing field if it's going to be serialized. As I mentioned, objects aren't serializable, so just kind of annoying. Sealed classes are supported, as we've sort of seen in a couple of examples, but the implementation isn't all that great. It basically just sort of throws an additional type parameter in it. And when you're trying to do any sort of custom serialization, or if you have complex hierarchy of sealed classes, it can get really confusing and very difficult to get the output you're looking for. I struggled with it quite a bit. It's very possible I just don't know what I'm doing, but I had a lot of problems with it. Once again, the sealed class support will be improved for version 1.0. That's another thing that the library maintainers are aware of, but just not available yet. The docs can tend to be a little out of date. Because the library is under such rapid development, a lot of the documentation doesn't get updated as time goes on, and some of the best practices that they list are maybe no longer the best practices. So a couple of times I was sort of going down one way and then realized there was sort of a better way to do it. So just something to be aware of. And if you get any weird errors when you're sort of working on this, before you start getting angry or pulling your hair out or anything, just try a Gradle clean, and probably like 80% of the time it's going to fix your problem. And then if it doesn't, then you can get mad and then sort of try and figure out what's going on. All right, so we're almost out of time, and I've sort of been rambling on, so you probably want to know if you should use it. So let's just quickly review sort of the pros and cons. So the pros, I mean, it's pretty easy to work with. It's not a lot of the code is just generated, and you're just kind of marking classes as serializable. It's a multi-platform library. So sort of following up on the previous talk about Kotlin multi-platform and Kotlin native projects, you can actually use this in a common module in that project. It will work in a multi-platform project, which is great, so that you don't have to have platform-specific serialization. It doesn't use reflection to generate or to do any of the serialization, so I get some performance increase. It's got built-in support of Kotlin features, such as sealed classes, even though they're not great, and it will have object support. And it's also sort of comparable speed when comparing to GSON and Moshi, so you're not really losing any performance. But again, there are sort of cons you sort of have to worry about. One is the API is experimental, so there's no guarantee it's going to stay the same. And even in my time working with the library over the last few months, some code I've written has now become obsolete. Sorry, went too far. It is, as I mentioned, got some missing features, such as object serialization. It does have some small bugs that I ran into. They are sort of actively being fixed. There's a lot of bugs in the GitHub repo that sort of people are working on. So it's, as I mentioned, it is under heavy development. And I guess another sort of thing is with the serialization code, because it's generated, you can't really go in and look at the code, at least not in an easy way. And so if you're looking to sort of see how it's doing a serialization, you can't actually see that, which, depending on your use case, that might or might not be an issue. And again, just I mentioned, the docs can be sometimes a bit out of date. So, but there is a lot of information just online in terms of blog posts and other things like that, where people are going through a lot of examples. Okay, so final decision: should we use it or not? I don't know. I think, honestly, I shouldn't say I don't know. I think it depends on your use case. I think if you are serializing simple objects, if you're starting a new project, if it's a Kotlin native project or a multi-platform, if you're looking to limit third-party dependencies, I think these are all good reasons to give it a shot. As I mentioned, it is under development, but as I said, if you're sort of in a situation like this, I think it makes a lot of sense. If you've got a production app and, I wouldn't go and replace your GSON instance with it. I don't know, maybe you guys are risk takers, but I mean, I wouldn't. And I also don't really think there's any benefit to it at this point. I mean, it's just sort of serialization. It's going to kind of give you the same output as another library. So, but I think it's going to become a lot more widely adopted as time goes on. And if you want to learn more, there's the GitHub repo, which also has a ton of examples on sort of how to use it, and the link to the Retrofit converter as well. And thank you very much. I know there was sort of kind of blew through it. There's a lot of info here. I posted the slides in the Slack channel, and if there's any questions, if anything isn't clear, please come find me. I'll be here for the next 2 hours, and we can talk about it. And I hope this was helpful for you. And thank you very much.